Three super cool buildings in Iran, a country with culture, structural intelligence, and architectural elegance.
Hi, we are with you from the Constructive Minds YouTube channel. This is the place where a team of engineering and architecture experts gathers to unlock the secrets behind the world's urban masterpieces for you.
That's right. On our channel, we've compared the construction industry of many countries around the world, like the US, China, Dubai, and the UK. We've constantly traveled between countries, spoken of the West and the East, and only one thing mattered to us: the world's bizarre buildings.
And we've always had one burning question: which country has the craziest and most technically advanced buildings?
Which country do you think? Well, after watching this video about Iran, where traditional architecture and modern engineering engage in a fascinating battle, your perspective is bound to change.
Iran is a country that, on the one hand, has structures that have rewritten the seismic rules for a height of 435 meters.
And on the other hand, it features monuments like Isfahan Square that were built with brick and mud, yet have resisted earthquakes and erosion for centuries. That is compression-driven engineering.
Today, we're not just going to talk about aesthetics. We're going deep into the steel and concrete of Milad Tower. How has such a massive structure remained standing in seismic Tehran?
And we'll analyze the astonishing stability of Safavid architecture through its compressive strengths, and examine the assembly process of the organic Tabiat bridge over a busy highway.
Hi, I'm Eleanor, meaning shining light, and I, along with my friend Theodore, want to take a look at Iran and analyze the structural secrets of three engineering wonders of this country.
We are with you from the Constructive Minds YouTube channel. This is where a team of engineering and architecture experts has gathered to uncover the secrets behind the world's urban masterpieces. If you love strange structures, engineering analysis, and bold architecture, then subscribe to the channel right now and hit the bell so you don't miss any exciting episodes.
Hello and welcome. Today we're going to unlock the engineering secrets behind some of Iran's most amazing superstructures. It's a story where ancient history and modern ambition are, believe it or not, built from the very same spirit of innovation. So, let's dive right in with the big question. How can a structure made of ancient brick and one made of modern steel, built 400 years apart, both tell the exact same story of engineering genius? That is the puzzle we are going to piece together today. Here's our game plan. We'll set the stage, then we're going to journey back in time to a 17th century masterpiece of brick and mortar. After that, we'll rocket forward to a modern concrete giant and finish up by exploring a futuristic forest of steel. And by the end, we'll see how they all connect to one single, unifying idea. At the heart of this whole story are three just truly remarkable structures. Each one faced enormous environmental and technical challenges in its day, and each one solved them with a kind of genius that was perfectly suited to its time. They're really a testament to resilience and just relentless innovation. Okay, our first stop is Isfahan's Naksh-e-Jahan Square. Now, this isn't just some historical site you visit on vacation. No way. This is like a living library of traditional engineering wisdom, a masterpiece built entirely of brick and mortar that has quite literally defied time itself. Let's just put this into perspective for a second. Construction started way back in 1598 and took over 30 years to finish. For more than 4 centuries, this massive complex has stood strong, surviving everything the world could possibly throw at it. So how on earth did they do it without a single piece of rebar or a drop of modern concrete? Well, the secret lies in one absolutely crucial concept: compressive load. The whole thing is a masterclass in managing compression. Every arch, every dome, every wall is perfectly designed to channel all that immense weight straight down, squeezing the bricks together and basically using gravity itself as a form of superglue. See, there are no forces trying to pull it apart, only push it together, making it stronger. And you know what? This obsession with compression is exactly what makes it a seismic survivor. The structure isn't just one building, it's an entire integrated system where the walls and even the market stalls all work together as one. The natural mortars they used had just enough give to absorb the energy from earthquakes. It's the power of pure geometry, arches and domes distributing weight so perfectly that it just stays stable. And that famous double-shell dome on the Imam Mosque, that's the ultimate example, an acoustic and structural marvel that's still standing because of these very principles. All right, now let's hit the fast-forward button and leap 400 years into the modern era to Tehran's Milat Tower. This is a different beast entirely. It's a symbol of modern ambition, built not with brick, but with a mountain of reinforced concrete and steel. But it's facing the same immense natural forces. The sheer scale here is just staggering. We're talking 435 meters tall, the highest structure in Iran. But here's the catch. It stands in one of the world's most active seismic zones, right near major fault lines. Building this high, in this specific location, well, it required a complete rethinking of structural engineering. So let's break down the anatomy of this modern giant. It's really a 5-step marvel. It all starts with a massive, 66-meter-wide foundation, anchoring it deep into the earth. From there, a transition structure funnels the load into the tower's core, a colossal 315-meter-tall concrete shaft. That's its unbreakable spine. And way up at the top, you've got this huge 12-story steel head, topped off with the antenna mast reaching for the sky. So how did they build that colossal spine so incredibly fast? The secret was a really cool technology called slip-form construction. Basically, it's a continuously moving mold that allowed the concrete shaft to literally climb upwards at an incredible rate of 4 meters every single day. And the amount of material they used, it's just mind-boggling. We're talking over 6,300 tons of steel for the skeleton, but the real star of the show is the concrete. Over 54,000 cubic meters of it. To put that in perspective, that's enough concrete to fill more than 20 Olympic-sized swimming pools. So this wasn't about clever geometry like before. This was about achieving stability through sheer brute strength and mass. For our final case, we're looking at something that feels like a vision of the future, the Tabiat Bridge, also in Tehran. This structure moves beyond just solving a problem. It asks a totally different question. What if engineering could actually harmonize with nature and the human experience? And the core idea behind the Tabiat Bridge is captured perfectly right here. It was designed to be a destination, not just a shortcut. Inspired by the way tree branches grow, it creates this amazing public space where people can meet, rest, and just enjoy the view. It completely changes the very definition of what a bridge can be. Structurally, it's an absolute marvel. It's what engineers call a space truss. Think of it as a complex, three-dimensional web of interlocking steer triangles that creates incredible strength with surprisingly little material. This web spans 270 meters, and the entire flowing, multi-level structure rests on just 3 massive, tree-like columns. It really does create the feeling that you're walking through a man-made steel forest. But, as you can imagine, bringing this organic vision to life was a massive technical challenge. Because of its complex, flowing shape, every single one of the thousands of steel pieces was unique. That meant they needed advanced digital modeling to design and create them with absolute precision. And then, as if that wasn't hard enough, they had to assemble the entire 2,000-ton structure over one of Tehran's busiest highways. Talk about a high-stakes operation. So, okay, we've got a masonry masterpiece, a concrete colossus, and a steel forest. 3 totally different eras, 3 different materials, 3 different philosophies. But if we look a little closer, we can find a common thread, a core principle that connects them all across the centuries. Let's just break it down. Back in the 1600s, Naqsh-e-Jahan used brick and the principle of pure geometry to last for centuries. Fast forward to the 2000s, Milat Tower used reinforced concrete and the principle of vertical strength to conquer height and seismic risk. And then, in the 2010s, the Tabiat Bridge used steel and the principle of organic form to create flow and human connection. You see, each one was the perfect, innovative solution for its time. So, what's that single thread that ties them all together? It's this: intelligent adaptation. Each of these structures shows a genius for using the best materials, the best technology, and the best knowledge of their day to not just solve a problem, but to create something lasting and meaningful, even in the face of these huge environmental challenges. And this really leaves us with one final thought to chew on. From the compressive genius of brick, to the vertical strength of concrete, to the digital precision of steel, we've seen what's possible. The question now is, what incredible legacy will the next generation of engineers build when they learn to combine the wisdom of the past with the amazing technology of the future?
Well, we've reached the end of our comprehensive analysis. Truly, after this detailed technical review, one must admit that the structures of Iran are outstanding.
Exactly. From the majestic Milad Tower's concrete shaft at that dizzying height to the subtlety and compression-based stability in Naxel Jahan Square's architecture, these are brilliant examples of engineering across time.
These three buildings demonstrated that engineering is not just about calculations and codes, it is an art of turning severe environmental and seismic limitations into lasting and iconic solutions.
Now it's your turn. If you've seen our previous videos on the structures of China, the US, or other countries, be sure to share your opinion on the technical comparison with these Iranian masterpieces in the comments section.
The challenge still stands. Which country has the craziest and most resilient masterpieces? What is your answer? Thank you for being with us.
This content was produced by the Constructive Minds YouTube channel. If you are interested in deep and engaging videos on construction and structures, subscribe to our channel, hit the bell icon so you don't miss the next video, and if this video was useful for you, share it with your engineer, architect, or construction enthusiast friends.